Hi everyone, I am JULKA. Today's topic is definite integral. In part 4, we'll talk about some more problems based on properties of definite integral. Example first, integration 1 to 5 in mod x minus 2 plus in mod x minus 4 respect to x. In this function we have two breakpoints, x equal to and the x equals to 4. And the 2 and 4 lies between 1 and 5. So we can redefine this function between 1 to 2, 2 to 4 and 4 to 5. Between 1 and 2, if we take any value, the both modulus are negative. So it is minus x minus 2 minus of x minus 4. Between 2 and 4, first is positive and the second is negative. And between 4 and 5, if we take any value, the both modulus are positive. Now we can redefine this function as 6 minus 2x when x lies between 1 and 2, 2 when x lies between 2 and 4, and 2x minus 6 when x lies between 4 and 5. Now we can rewrite this quotient, integration 1 to 2, 6 minus 2x respect to x plus integration 2 to 4, 2 dx plus integration 4 to 5, 2x minus 6 respect to x. Now we can solve this question simply and we'll get the answer. Next example, integration minus 1 to 3 by 2 in mod sine pi x respect to x. First we find breakpoint of this function. First we take sine pi x equal to 0. The value of sine is 0 at 0, pi or 2 pi. So the value of x is 0, 1 or 2, but 2 don't lie between minus 1 to 3 by 2. So we will take only 0 and 1. Now we have two breakpoints, 0 and 1. So it is minus 1 to 0, plus 0 to 1, plus 1 to 3 by 2. And the function is in mod sine pi x. In minus 1 to 0, in minus 1 to 0 means sine pi x lies between minus pi to 0, third and fourth quadrant, where sine pi x is negative. If we talk about 0 to 1, it means sine pi x lies in 0 to pi, first and the second quadrant, where sine pi x is positive. In 1 to 3 by 2 means sine pi x lies between pi to 3 pi by 2, third quadrant, where sine pi x is negative. So we can rewrite this question, minus 1 to 0, minus sine pi x respect to x, plus integration 0 to 1 sine pi x respect to x, minus integration 1 to 3 by 2 sine pi x dx. Integration of sine pi x is minus cos pi x upon pi. And we apply this formula in all the three parts. In the first part, limit is minus 1 to 0. In second part, limit is 0 to 1. In the third part, limit is 1 to 3 by 2. After putting upper and the lower limit, we will get cos 0 is 1, cos 180 is minus 1, and cos 3 pi by 2 is 0. After putting the value, we will get the answer 5 by pi. Next example is a very important question. Integration 0 to pi by 2 log sin x respect to x. We will take quotient equals to I. So it is 0 to pi by 2 log sin x dx. Take this as a first equation. Now after using property 0 to a, f a minus x will get sine pi by 2 minus x, and sine pi by 2 minus x is cos x, so it is 0 to pi by 2 log cos x dx. Take this as a second equation. Adding first and second, we will get I plus I is 2i, limit 0 to pi by 2, log sin x plus log cos x, which equals to log sin x into cos x, because log m plus log n is log m into n. And And now you just multiply by 2 and divide by 2. And we will get 2y equal to integration 0 to pi by 2 log sine 2x minus log 2. Now put 2x equal to z. When we differentiate respect to x both sides, we will get 2 equal to dz by dx. So dx equals to dz by 2. So 2y is log sine z dz, because in place of dx we write 1 by 2 dz. And now when we change the limit. When x is 0, z is 0. When x is pi by 2, z is pi. So limit is now 0 to pi. In the second part, answer is x log 2, limit 0 to pi by 2. Now 2y equals to half 0 to pi log sine x dx. We can use this property. A to b fx dx equals to A to b fj dz. We can replace z by x or x by z. And the second part is pi by 2 log 2. Now again, function is log sine x. If we use pi minus x, sine 180 minus theta is sine theta. So it is equal to fx. Now there is no change in the function. So we can use this property. 2y equals to half outside twice of 0 to pi by 2 log sine x dx minus pi by 2 log 2. Now this is a repetition of question. So 2y equals to I minus pi by 2 log 2. After further simplification we will get I equals to minus pi by 2 log 2. Remember the answer of this question because we will use this answer in the next questions also. Next example. Solve 0 to pi log 1 plus cos x respect to x. We will take this question equals to I and take as a first equation. Now we use property 0 to a fx dx equal to 0 to a f a minus x. Here a is pi and x is x. So it is log 1 plus cos pi minus x. Cos 180 minus theta is minus cos theta. So I equal to 0 to pi log 1 minus cos x. Now take this equation as a second equation. Adding first and second, we will get 2y equals to 0 to pi log 1 plus cos x plus log 1 minus cos x, which equals to log 1 minus cos square x, because log m plus log n is log m into n. Now it is 0 to pi log sine square x. Log m to the power n is n log m. So it is twice of 0 to pi log sine x. Here fx is log sine x. If we use a minus x means pi minus x, so it is log sine pi minus x. There is no change in the function. So I equals to twice of 0 to pi by 2 log sine x. And the answer of 0 to pi by 2 log sine x is minus pi by 2 log 2. So I equals to twice of minus pi by 2 log 2, which equals to minus pi log 2. Here we use the answer of the previous question. Last example. 0 to pi x log sine x respect to x. We will take this question equals to I. I equals to 0 to pi x log sine x dx. We take this equation as a first equation. And now we use property 0 to a fx equal to 0 to a f a minus x. So in place of x we write pi minus x. Sine 180 minus theta is sine theta. So I equals to 0 to pi minus x log sine x. Take this equation as a second equation. Now adding first and second, and we will get 2y equal to 0 to pi x plus pi minus x and the log sine x dx. X cancel by x. Again function is log sine x. If we use here a minus x, pi minus x, there is no change in the function. So we can use property 0 to 2a fx dx equal to twice of 0 to a. So it is twice of 0 to pi by 2 log sin x and we take pi outside. Again, the answer of 0 to pi by 2 log sin x is minus pi by 2 log 2. So the answer is minus pi square by 2 log 2.